If a tree falls in the forest,
I know this question.
okay, no, that's not my question actually.
Actually, I'll answer that one if you like. I've got a good answer for that, but go ahead, go on to this.
Okay, looking outside at night,
Right.
clear sky, and you see a star burn out.
Right.
And supposedly you're told that this star burned out thousands and thousands and thousands
Millions
of years
ago.
Millions of years
10
ago.
million years ago.
Okay.
Fine.
I mean, how do you explain that the fact that the star had already burned out then supposedly then by the time God had created the earth?
Okay. There's three, what he's asking is a fundamental question about how do we explain a universe that looks like it's millions and millions of years old. I mean, the scientific evaluation in astronomy seems to indicate that, okay? You see redshift, you see the background radiation, you see all those things in astronomy that would indicate this universe is really millions of years old, and the measurements of light from distant objects, okay? So how do you answer that question? Creationists have had three classical answers to that question, okay? One is recent, the two are old ones, okay? I'm going to give you the two old ones first because I'm going to hold the recent one for last because it's going to take a little time to do that. The first one is simply that when God created the universe, he created it fully functioning. That is, the light was from here to there already existing, okay? Just like he created Adam, fully formed, mature person. He created the universe fully formed, fully functioning, okay? That's not a very good scientific model because it can't be investigated. It's just a statement of dogma, okay? It's one creationist explanation, but it's a dogmatic statement. That's not very satisfactory. The second one is that because when the Bible tells us that on day one God created light, that when he created light at the very beginning, light speed was almost infinite. And then light speed deteriorated to the point where now it's at the current level. And as a result, that light's not really 10 million years away. It's really only hundreds of years or thousands of years away because the speed of light has come down. There's been some research done on that by Barry Setterfield. The research is ambiguous, but there is some indication that, in fact, the speed of light has declined extremely slightly in the last couple hundred years since it's been measured. Now, the problem is that would be an asymptotic curve, and we'd be on the end here where the changes would be very small over long periods of time, okay, if it came up from almost infinity down to the current level, okay? That's, again, not terribly satisfactory because we need a couple thousand years to measure that, and none of us are going to live that long. So that's another explanation that could be the right answer, but it's not satisfactory. The third explanation uses modern physics to answer the question, okay? And this is going to take a couple, can you give me 4 more minutes? Okay. I'll go for a little while longer. I'm not that tired. But my camera's going to run out anyway, but that's okay. Doesn't matter. We've got enough for TV. Let me give you the third argument, because this is the best one. Okay, and I've got to step back now, and I've got to do some basic education here. Einstein's theory of relativity. Okay, when Einstein declared relativity in the middle of this century, when Einstein made his basic statement of relativity, he disrupted Newtonian physics, okay? We have two physics now that exist, Newton's physics and Einstein's physics, okay? And the physicists are working on a third one called, not uncertainty, but called, help me with it. No, I'll get to it. It'll come back. Just, I'm focused on Einstein for the moment. Okay, so we've got Einstein and we've got Newton, okay? In Newton's physics, time is fixed. Time is fixed everywhere in the universe. Time doesn't change. In Einstein's physics, time changes based upon gravitational effect, okay? Now, Newton's physics works very well, except that when it comes to time, we've measured time and time does change. Okay, gravitational effect does affect time. The clock actually runs, the atomic clock at sea level runs slower than the atomic clock in Denver, Colorado. We switched clocks and done it all that way in a couple microseconds a year. So gravity affects time, which simply means that if there were a black hole, and black holes are theoretical, if there were a black hole, the clock would run really slow close to the black hole, okay? And the clock would run faster away from the black hole. All right, now, having made that statement about time, I have to go back and tell you about the Big Bang. The Big Bang is based upon Einstein's relativity. It makes some assumptions in order to run the model, okay? Einstein's relativity is really a whole series of equations, and to run the model, you've got to make some assumptions. These are the assumptions you make for the Big Bang. The universe is uniformly distributed. The universe has no boundaries. The universe has no center. Okay? If you make those assumptions and you put in Einstein's model, you can generate a Big Bang. Okay? But Dr. Russell Humphreys at Sandia Laboratories said, wait a minute, those are not realistic assumptions. We know the universe is not uniform. I mean, it's full of lumps. It's lumps all over the place. In fact, the evolutionists have tried to explain that by something called cold dark matter. Can't see it, can't find it, but it must be there. A tremendous statement of faith, but having no logic. And you know, in the Big Bang model, 90% of the universe is missing. It's missing. For the Big Bang to work, they've got to have 90% of the mass is not seen. Okay, that's first thing. Second thing is Humphrey said, wait a minute. The universe does appear to have boundaries and limits, and it does appear to have a center of mass. And the center of mass would appear to be somewhere near us because we see matter in every direction. If we're on the fringe, we should see matter not in one direction more than the other. We see matter in most directions, so we must be somewhere near the center. So Humphrey took those parameters and ran the model. Okay? He got a bang, but he didn't get a big bang. He got something called a white hole. And the difference, and I'm going to get technical and mention it, and I'm not going to explain it. The difference is the event horizon moves inward instead of outward. And what that does is that gives you a universe where, listen to me, it gives you a universe where the clock runs slowest here. 24 hours is passing here, today. And 10 million years have passed at the edge of the universe at the same time. Blows your mind. Scrambles your eggs. Okay? You don't have a clue. I don't fully understand it either, but Humphreys has written a book. The book's called Starlight in Time. Unfortunately, the books are packed up, but the book's called Starlight in Time if you want to pursue it, okay? It's just a recently developed model, but it answers the question of distant objects being here in a universe that's only 6,000 years old. And when I read Russ's book, I saw Russ about 3 months after I read the book, and I said, you've done a tremendous work for us because you've taken the modern physics we understand and applied it in an area where we can say, now we have an answer to how the universe can look the way it does. Let me give you one more example on the universe. And if I've given you this example already, because I can't always keep track of what I've said to who, if I've given you this example, stop me, okay? The ancient astronomers looked at the stars at night. Did I talk about that? And they counted them. 6,000, okay, all right, I've covered that, I'll stop that. They counted them. The ancient astronomers, I'll do a quickie. The ancient astronomers counted the stars. Conclusion, firm finding of their science was 6,000 stars. We counted them, we know them, we've numbered them, we've named them, we know how many there are. But the Bible said the stars are like the grains of sand on the beach. The question is, which one's true? The ancient astronomers were wrong. The Bible was right. Okay? The Bible's always right when it makes scientific statements. I mean, did Job have a clue what he meant when he wrote the earth hangs on nothing? He probably didn't. But you've seen the NASA pictures. The earth hangs on nothing, right? I mean, there's just hundreds of examples of that kind of stuff in the scriptures. You know, atomic theory is mentioned in the scriptures. You know that second law of thermodynamics is mentioned in the scriptures. It's all in there. The makeup of the matter on the table is mentioned in scriptures. So it's all there. I can't spend any more time on that, but it's all there. In great detail in some cases.